Alright, in this video we're going to cover Objective 4, which is about bone formation and development from Chapter 6. We actually really didn't get a chance to go into this in great detail in class, so definitely want to make a video for this one. It is kind of complicated, and honestly what we're going to read about and see is kind of a simplification. It doesn't feel very simple, but it's actually kind of simplified. And so hopefully we know already that in early development, the embryo is actually not bone at all. It's actually mostly hyaline cartilage. And so bone development doesn't actually begin until around 6 to 7 weeks. And then it will continue all the way up into young adulthood. And so bone development is actually called ossification, or it could also be called osteogenesis. And so there's two main ways that bone is made. You have intramembranous ossification and endochondral ossification. So in intramembranous ossification, this is really one of the main things that you need to understand, is that the bone is developing straight from those stem cell lines, the mesenchymal connective tissue. Remember, that is your precursor tissue. That is a stem cell line that you'll find that forms from the mesoderm, that embryonic tissue layer. And so here we have bone developing straight from that embryonic tissue. And so we'll find that in the flat bones of our face, the cranial bones, and our clavicles. This starts in utero, and this continues all the way into adolescence. Now, the basic process. Once again, this is kind of simplified and summarized, so I know it seems like a lot. I think the pictures are great in trying to help explain it a little bit better. But essentially those stem cells are going to group into clusters, and they're going to become those osteogenic cells, those precursors to bone. And then osteogenic cells will become osteoblasts. Remember that these are your bone builders, okay? And they're going to form what's called an ossification center. And then the osteoblasts are going to be secreting osteoid, which is the matrix. At this point, it's uncalcified when it's first secreted, but it's going to become calcified. And once it does, it's going to trap those osteoblasts, and they're going to become those mature bone cells called osteocytes. Now, the osteoid, which is that matrix that's going to form around the capillaries, and it's going to create what's called the trabecular matrix. So that's, remember, the trabeculi is what you find in your spongy bone. And then the osteoblasts that are kind of on the outside are going to form that periosteum, that kind of lining, that fibrous tissue that surrounds our bone. So that periosteum is going to create that protective layer. We're going to have compact bone forming. Remember, the compact bone is going to be superficial. It's going to be on the outside. That spongy bone or trabecular bone is going to be on the inside. And then inside, where we have the trabecular bone, it's going to crowd around blood vessels, and it's going to become your red bone marrow. All right, so those are going to be the basic steps. Once again, that is kind of summarized. So you're welcome to go into your textbook and read into it in a little more detail. But there you have your basic processes, your ossification center. So we start with the mesenchymal stem cells. They become osteogenic cells, which become osteoblast. They form the osteoid, which is the matrix. They're going to trap those osteoblasts, and they'll become osteocytes, and we'll get more of that calcified matrix. We're going to have the formation of the trabecular bone and the periosteum, and then we're going to have the formation of that compact bone on the outside and the red marrow on the inside. All right, an endochondral ossification. Okay, remember that this prefix here means cartilage. So this is where bone develops by replacing cartilage. It is important that you understand that cartilage doesn't turn into bone. The cartilage is replaced by bone. And this can take a lot longer than intramembranous ossification. And you can find this in your long bones, and you can find this at the base of your skull. Once again, we kind of have a set of main steps. This is simplified. You're welcome to read about it in more detail in your textbook. It is going to start with your mesenchymal stem cells again, but this time they're forming cartilage. They're going to form chondrocytes, which are cells that make up cartilage, and they're going to form a cartilage template, and they're going to form what's called the perichondrium, which is the outer layer of your cartilage. Okay. Then in the center, the chondrocytes are going to get bigger. They're going to hypertrophy, which means they just grow in size. And as that matrix begins to calcify, it's going to kind of block the nutrients from these cartilage cells. And so then the chondrocytes begin to die, and the cartilage begins to disintegrate. Now, as the blood vessels invade those spaces where those cells are dying, they're bringing those precursor to bone cells, your osteogenic cells, and then your osteogenic cells will become your osteoblast. And so the cartilage is going to continue to grow, the capillaries are going to penetrate. The perichondrium, which was around the outside of the cartilage, is going to become the periosteum, which is going to be the outside of the bone. And then that collar that kind of surrounds that bone is going to develop, and what we call the primary ossification center is going to be on the inside, deep inside of that, essentially the periosteum. And then we're going to get secondary ossification centers at the ends of those bones. Remember, this is happening in your long bones. And so in those epiphyses, we're going to have our secondary ossification centers. Cartilage does remain there for a little while. That's how we're going to grow in length. Remember your epiphyseal plate. And then we're still going to see some cartilage at the joint surface. But as a whole, all of that cartilage is going to have been replaced by bone. And so there you see endochondral bone formation. So it starts with your cartilage. The cartilage is going to calcify. The cartilage cells are going to get bigger and die. We're going to have the formation of the outer bone material, the periosteum and the primary ossification center. And then we're going to have the secondary ossification centers forming in those epiphyses. All right, endochondral ossification forms which type of bones? That is going to be our long bones. All of these other ones are formed by intramembranous ossification. And then intramembranous ossification is best described as, remember, it comes directly from the mesenchyme. So mesenchyme cells are directly converted into bone. All right, so let's take a look at our steps, okay? So the first thing that has to happen is we have to have our mesenchymal stem cells. We're going to start there. All right, let's see, after that, those osteoblasts are going to become trapped. It's going to be step 2. All right, we're going to have the trabecular bone is going to form next, that spongy bone, and then the periosteum on the outside. Then the compact bone is going to form around that spongy bone, and then the blood vessels will form the marrow. All right, same thing for the endochondral. All right, we're going to start with mesenchymal cells again. Remember, those are going to be our stem cells, so that's going to be step 1. This time they're going to form cartilage. The chondrocytes are going to die as they get bigger, or they're going to get bigger, and then they're going to die. That's what apoptosis is cell death. We're going to have the formation of our primary ossification centers first, and then our secondary ossification centers. All right, so in addition to that, once the bones are formed, they can also grow. And so we're going to look at growth in 2 different ways, growth in length and growth in width. And so when we're talking about growth in length, that's going to occur at the epiphyseal plate. Remember, we have a little thin layer of articular cartilage, hyaline cartilage there. And so on the epiphyseal side, so on the ends, you're going to have new cartilages formed. And then on the diaphysis side, so here on the kind of the inside, this is where the cartilage is going to be ossified. So that's where the new bone is going to be forming. This is going to take place up until early adulthood, and then at that point your epiphyseal plate is going to turn into your epiphyseal line. This growth is regulated by hormones. We'll look at that in a little more detail here in a little bit. And then once again, after that longitudinal growth stops, that's when that cartilage is going to be replaced by just the epiphyseal line. And so how it's going to happen is we're going to have these 4 different zones. They contain different cells and different activities. So the reserve zone, this is actually where we don't really have the growth occurring. It does contain those cartilage cells called chondrocytes, and they're just going to secure the plate to that bone tissue, that osseous tissue. And then this is the part that is closest to the epiphyseal end. And so as we're going down, we're getting closer to the diaphysis. So the proliferative zone, proliferate means to make more of, to divide. And so this is where we have a lot of mitosis. And so those chondrocytes are going to be going through cell division, and they're going to be making new chondrocytes. And then they're going to mature, and they're going to get bigger in the next zone, maturation and hypertrophy zone. So they're getting older, they're getting more mature, they're becoming bigger, and this is the point at which that calcification is going to begin. And then in the calcified matrix zone, this is when the matrix is going to be fully calcified. That makes it difficult for those chondrocytes to get like blood and things like that, and so the chondrocytes begin to die. Then the capillaries are going to penetrate the spaces once those cells die, and then osteoblast will be brought in, and that's what's going to create that new bone tissue. So there's your four different zones. So up here is your epiphysis, and then down here is in the shaft of the bone, and you can see that as we're moving down, we're going from some cartilage cells to ossified bone. And then we also have bone growth in diameter. Okay, your bones will get wider. This is known as appositional growth. Even when our length stops growing, your diameter can continue. And so this is going to involve 2 types of bone cells. We're going to have our osteoclast, and we're going to have our osteoblast. Remember that your clasts break and your blasts build. And so your osteoclasts are going to resorb the bone that's on the inside, and then your osteoblasts are going to produce new bone kind of on the outer layer, right below that periosteum. And so they kind of work together in coordination. And so the osteoclasts break, and then the osteoblasts build new, and as they do that, they're going to make both the diaphysis wider, and they're also going to increase the diameter of the medullary cavity. And this is called a modeling, okay? And our bones are constantly being remodeled as they're exposed to stress and damage and things like that. All right, so there you have your bones widening or your appositional growth. All right, so at the epiphyseal plate, the bones grow, okay? The epiphyseal plate is involved in the length. Cartilage is formed on which side of the epiphyseal plate? That's going to be the epiphysis side. Remember that on the diaphysis side is where we're going to be building and creating the new bone. And then in what zone do the chondrocytes die? So the reserve zone, they're living cells, they're multiplying in the proliferative zone. They're beginning calcification in the hypertrophy zone. They're mostly just maturing and getting bigger. But once they become fully calcified, then they start to die. And then appositional growth is when bones get wider. That's growth in diameter. And that wraps up our objective 4.